As you explore this lab, take note of the two key parts. Part one, which is the reaction between silver nitrate and potassium chromate. And then part two, which is the reaction between the solid silver chromate that was made in part one and potassium chloride. Students will be exploring the difference between the KSP values for each of those substances. First thing I'm going to do in the progressive precipitation lab is I'm going to mark two test tubes, 2 milliliters, 4 milliliters, and 10 milliliters. Technically, the instructions do say to have two test tubes, but for the purpose of this demonstration, I'm just going to do one. The purpose of the first test tube is just for comparison to what happens in part two of this lab. So in part one, we're going to have 2 milliliters of 0.1 molar silver nitrate. Excuse me, 0.2 molar silver nitrate. And we're going to add 2 milliliters into this test tube. And then to that, we are going to add 0.1 molar potassium chromate solution. And students are to take note of the color of each of the solutions. And the markings that I put on there are simply for speed. You don't have to do that. You can have the students measure 2 milliliters and of each of those solutions. And since the volumes don't have to be precise for this, it's a quantitative lab rather really than a qualitative one. Or excuse me, it's a qualitative lab rather than a quantitative lab. The measurements don't have to be precise. So I'll have my 2 milliliters of silver nitrate in there, and then I will put the potassium chromate in. And you can see that that forms a nice, very cloudy, reddish brown precipitate in there. And that's great as they think about what KSP means, or just plain old solubility rules. You get a great precipitate there. You can let that sit, and that's another benefit of having just having two test tubes. They can let that one sit and see the solids settle out. It settles fairly quickly. It might even settle significantly here while I'm doing this demonstration. So then there are several questions within the lab that they have to answer. And then they get to part two, where they're going to add potassium chloride to what's already in that test tube. And so again, one test tube will be for reference. The second test tube, now they're going to add the potassium chloride solution to that. And I have the procedure is adding an excess of potassium chloride because I want there to be no doubt in the student's mind which substance is less soluble, right? Which one has the smaller KSP. So I'm going to go ahead and add 6 milliliters. I might have said 10 before, but I'm going to add 6 milliliters up to the 10 milliliter mark. And instantly you can see that solution becoming yellow. And hopefully students conclude that that's the reappearance of the chromate ion in solution. And then they'll have a stirring rod. And as they stir, and this might take a little bit, they should see that red precipitate become white, or that's how they might describe it. Right, the precipitate changed color rather than a new precipitate forming. And this does take a little bit of stirring and a little bit of patience. And if I stop stirring, you can see the white silver chloride precipitate forming. So ultimately they are comparing here, and I love it when labs give a nice visual, clear visual response to support the chemistry that they're learning. I don't want there to be ambiguity at this point. I kind of hate it when labs end up being not so clear. Like, yeah, we should have produced 2 grams of this and we only produced 1.5 grams. That's opportunity for great discussion, right? What could have gone wrong? What was wrong with our experimental procedure? Or what mistake did we all make in the lab? Sometimes that happens. But in a qualitative lab such as this, I really want there to be no room for misconception or doubt. And so you can see now that all of that precipitate, or virtually all of it, and if I stir for longer, all of it has magically changed color. And it's a nice quick lab. All right, clearly we've got the yellow of the chromate. We've got the white of a new precipitate forming. And so students can clearly see, practically see the difference, what a difference in KSP means, and perhaps even how to think about solutions that are competing, right? How do we precipitate this ion first versus that ion? So I hope this is helpful as you look through the progressive precipitation lab and answer some of the questions and think about ways that you might be able to use this in your class.